equations solving for two different variables. So if I gave you this problem, somebody give me one answer for what x and y would be. Just one answer. Yeah, Jay. 5 and 5. They could be 5 and 5. That would work, right? What would be another one? 6 and 4. What would be another one? 8 and 2. What about another one? 9 and 1. 7 and 3. 10, 0. Yeah, you could start throwing negative numbers in there, right? You could start flipping these around, right? How long would this list go on? Forever, right? Because you could start throwing in decimals, fractions, negative numbers, positive numbers. It's impossible to list every combination of this, right? That both x and y could be. It would go on forever. Okay. It would go on forever. Now, what if, though, I put some restrictions on it? Like, for example, I said, okay, x plus y equals 10, and x minus y equals 3. Could you think of an answer that works for both of these? It means it works for this one, and it works for this one. So I have multiple equations with two variables. Could x be, what could y be that works for both of these? Give everybody a chance to think about it here a second. Yeah, what is it?
No, I was going to say we should just graph it.
Yeah, we'll come to that in just a second, you're right. But what about guess and check wise? 7 and 3 would work for this one, right? 7 plus 3 would be 10, but 7 minus 3 would be 4, so it wouldn't work for this one. Is there one that would work for both of these?
I got one.
Yeah, that would work, right? If you take 6.5 and 3.5, right? Add those together, you get 10. Subtract those, you get 3, right? But that one took a while guessing and checking. Okay? You would have to really start thinking about it, because then I could start throwing in problems, like this. And, those to guess and check for those two, that what would work for x and y would take a long time, right? So we need a better method than guessing and checking. Now, all we're going to do over the next 2 weeks is go over methods of how to solve these types of problems. Two variables, multiple equations. Okay, and the first one we're going to talk about today is graphing them. Okay, and what happens if we graph these. So on your first graph there, I want you to first graph. So on your first graph, I want you to graph these two lines on the same graph. On the same graph. Go ahead and graph both of those on the same one. Y equals 3x minus 4 and y equals negative 3x minus 4. Graph both of those on the same one. So you should have two lines that look kind of like that, right? Kind of in a V-type shape, right? So that this one, 3x minus 4, I started at minus 3, right? Or sorry, minus 4 on the y-axis, then I went up 3 over 1, up 3 over 1. This one, I started also at minus 4 on the y-axis, and I went down 3 over 1, which is also the same thing as going up 3 back 1, since I ran out of room here. Okay? But if you keep extending that line, you should get something that looks like these two lines. Okay? Now again, our goal here is to figure out what can x and y be that works for both of these problems, right? What can x and y be that works for both of these problems? Now, one way we can do it is we can start guessing and checking. We can say, okay, x is 1, y is 1, let's plug them both in. Like for example, if I did that, if I plugged in x is 1 and y is 1, here I would get 1 equals 3 minus 4. 1 equals negative 1. That's not true, right? 1 doesn't equal negative 1 if I plugged in 1, 1. So I know 1, 1 doesn't work. But I want something that works for both this equation and this equation. But after I graph them, okay, I can actually find that answer pretty quickly. Where do we think that answer lies on this graph of the x and y that works for both of these problems? Yeah, Chase. Right, so all of these points on this line work for this black equation. For example, this is the point 2, 2, right? If I plug in 2, 2 here, this is going to be true. 2 equals 3 times 2 minus 4. 2 equals 6 minus 4. 2 equals 2. That works, right? But if I plug in 2, 2 here, I'm going to get 2 equals negative 6 minus 4, which is negative 10. It's not going to work there. Again, for example, if I picked another point on this black line, this is 1, negative 1, right? So if I plugged in, that's x, that's y. If I plugged in negative 1 equals 3 times 1 minus 4. I plugged in 1, negative 1 here. Negative 1 equals 3 minus 4. Negative 1 equals negative 1. That's true. That works. Right? So all of these points that lie on this black line work for this equation. All of these points that lie on this red line work for this equation. I want the point that works for, or the xy coordinate that works for both of these. Yeah, Jack?
That's the intersect?
Yes, it's where they intersect, which is right there. What point is that?
0, negative 4.
0, negative 4. Remember, that's the x coordinate, that's the y coordinate. So let's try both of those. Yes, question.
On the red line,
Uh-huh.
do you have to go up or can you go down 2?
You could go down 3 and over 1, but just if you extend the line, it should look like this.
Because I went down the lines, or the dots couldn't meet the lines.
Down 3, over 1, down 3. That's fine. You just need to extend your line here. Okay. So, yeah, this intersection point where they both cross each other is at 0, 4. So let's try both of those. This is the x coordinate. This is the y coordinate. So in this place, I'm going to plug in negative 4 equals 3 times 0 minus 4. Is that going to work out to be true? Negative 4 equals 0 minus 4. Negative 4 equals negative 4. That one's true. Let's try it for the other one. Plug in negative 4 for y, 0 for x. Negative 4 equals 0 minus 4. Negative 4 equals negative 4. True also. It works for both of them, right? Much easier than guessing and checking. Where they intersect, we call that a solution to this system of equation, a solution to both of these. X would be 0, y would be negative 4. That works for both of these. I graph them and find out where they cross, and where they intersect. All right, let's try another one on a new graph. Graph both of those on a new graph and see if you can find an xy coordinate that solves both of these equations, or that satisfies both of these. So you should get two lines that look like this, right? The blue one, or in my case, my blue one, I started at negative 4 on the y-axis. I went up 1 over 1 because it's positive 1 over 1, up 1 over 1. I just did that several times so I could get a more accurate line. Okay. The other one, I started at minus 2 on the y-axis. I went up 1 to the right 3, up 1 to the right 3, up 1 to the right 3. If I wanted to, I could have went down 1 and back 3, negative over negative. It would put me down here. So I'm trying to find an x and y coordinate that work for both of these equations. What do we think that xy coordinate is? 1, 2, 3, negative 1. They intersect right here, so it should be 3, negative 1. That's my x, that's my y, because we always write the x first. If we want to check our answer, we can do that by just plugging those in. Again, this is x, this is y, so let's plug them in and check and see if we get something true. Negative 1 equals 3 minus 4. Is that going to be true? Yeah. Yep, that'll work. Okay, let's try the other one. If I plug in negative 1 here, equals 1/3 times 3 minus 2. Well, 1/3 of 3, that's 3 over 3, which is 1. Negative 1 equals 1 minus 2. That's negative 1. That works also. So that is my solution to these two equations. Positive 3, negative 1 is the xy point that works for this one and this one. Okay. All right, so that's 2 of them. Let's try this. Graph both of those. So you're going to have to put them in slope-intercept form first, but then graph both of those and see what you get. So again, they're not in slope-intercept form to graph. Right. So I could put this in slope-intercept form by moving this x to the other side of the equal sign. Since it's a 1x, I just subtract 1x from both sides. And I get y equals 4 minus x. Same thing over here. I need to put that in slope-intercept form, get y alone. Move that 1x to the other side by subtracting it. I get y equals 1 minus x. So now they're both in slope-intercept form. The slope and the y-intercept switch spots, but that's okay. So for this line, I'm going to go to positive 4 on the y-axis. 1, 2, 3, 4. And it's a negative 1 slope, so that means down 1 to the right 1. It should be a downhill line. It looks like that. For this one, it's at positive 1 on the y-axis, and it's going to be down 1 over 1. Down 1 over 1. Also downhill. What do we call... First of all, are these two lines ever going to touch? No, because they're both going down at the same rate. They're both going down 1 over 1. Their slopes are the same. Right? This one has a slope of negative 1. This one has a slope of negative 1. They both started at different points, or they both go through different points on the y-axis, but they're never going to cross each other. They're going to keep going down the same rate. They could go forever in this direction, forever in that direction, and they'll never cross. So how many solutions, or how many x, y answers do you think there are that work for both this equation and this one? Since they never cross, there are no solutions to this system. Because they never cross. Okay? They never intersect each other. There's no solution. Okay? They never intersect, so there's no solution. Their slopes are the same. Right? Both their slopes are negative 1. So oftentimes, a lot of times when you start graphing them, you'll see the slopes are the same. As long as they're not the same line, they're going to have no solution. Okay? All right. We're going to do about 1 or 2 more here. So we're going to graph both of those. Neither of those are in slope-intercept form, right? So we can put them in slope-intercept form pretty easily. On this one, we can move the 2x over by subtracting it and then divide by 4. So we're going to get like 1/2 as a y-intercept. Here's one thing I will not do on a quiz or test. I will never give you a solution that, for example, let's say I have a line here. If I graphed them and a line going here. So the answer to these two lines would be this. I don't know if that's 1/2. I don't know if that's 2/3. I don't know what that exact point is. If there's ever a solution, it will be at an intersection point of 2 integers. Like 1, negative 1, 3, 3, 4, negative 2, something like that. Okay. So this one's probably a bad example, but let's try it anyway. Okay. Because, does anybody remember the way, one way we can graph without putting it in slope-intercept form? We did it a long time ago, like this. We made what we call a t-chart, and we just started picking stuff for x and found out what y equals, and then graphed those points and drew a line. Yeah.
Didn't you use -2, -1, 0, 1, and 2?
Yeah, that's the easy points to use, right? If you use, let's say, -1, 0, 1, and 2. Let's use those 4 points. If we plug them in here, what's y going to be? If I plug in -1 here, that's 2 times -1, which is -2. I would add 2 to both sides, which make this 4. And then I'd divide both sides by 4. Y would be 1. Now, if you put it in slope-intercept form, it should still go through these points. If I put in 0 for x, this whole thing becomes 0. And I would just divide both sides by 4. 2 divided by 4, 1/2. If I plug in 1 for x, this becomes 2 times 1, which is 2. Subtract 2 from both sides, this becomes 0. Divide both sides by 4, still 0. If I plug in 2 for x, that becomes 4. 2 times 2 is 4. Subtract 4 from both sides. 2 minus 4 is negative 2. Divide both sides by 4. Negative 2 divided by 4, negative 1/2. So let's plot these points. Negative 1, 1, 0, 1/2, 1, 0, 2, negative 1/2. So even if you put it in slope-intercept form, you should get a line that looks like that. Right? Let's go ahead and put this one in slope-intercept form. You can make a T-chart again and just start picking x's and y's to graph it like we did here. Let's put this one in slope-intercept form. Move the 3x to the other side by subtracting it. I get 6y equals 3 minus 3x. Again, I can't subtract these, they're not like terms. Divide both sides by 6 to get y by itself. Y equals 1/2 minus 1/2 x. Because 3 over 6 is a half. So I'm going to start at 1/2 on the y-axis. And I'm going to go down 1 over 2. Down 1 over 2. What happened to these two lines? They're the same line, right? Now again, I will not give you one where it's like a half here and you got to go down 1 over 2. You can, if you're just staying at a half each time. But they're the same line, right? Both of these equations represent the same line. So how many answers do you think there are that work for both of these if they're the same line? Yeah, we call that infinite. There are an infinite amount of solutions that work for this. Negative 1, 1 works for this and this. 0, 1/2 works for this and this. 1, 0 works for this and this. And I can just make this list. Every point that lies on this line would work for both of these because they're the same line. Yeah.
Couldn't you do just one, or go up 1 over 2, up 1 over 2 for both of them?
If I went up 1, I'd have to go back 2 because it's a negative slope. Negative 1/2 is a slope. But these two are the same line. These two equations, when I graph them, they're the same line. If you ever get the equation that are the same line, we call that infinite amount of solutions. Because every point that lies on this line works for both this one and this one. Okay. There you go. It's asking me to graph, find if is there one solution to this problem, infinite or none. Okay, to number 5. Let's look at this first, this top equation here. This isn't in slope-intercept form, right? So one way I could start to put it in slope-intercept form is I could move this 2x to the other side by subtracting it. But what would happen to this y, or what am I left with if I move that 2x over there? I'm left with negative y. That's okay, but if you do that, then you've got to go through and divide everything by negative 1. So for example, you could do this and get negative y equals 1 minus 2x, and that's like negative 1 times y, so I'd have to go through and divide everything by negative 1. You could do that, okay? But another way is just to make that negative y positive. Meaning, if instead of moving this 2x over to the other side, how would I move this minus y to the other side? Since it's a minus y. I'd add it, right? Plus y. I'd be left with 2x equals 1 plus y. And then if I want to get y isolated here, move the 1 over to the other side. That's a positive 1, so to move it over, I would just subtract it from both sides. And I'm left with 2x minus 1 equals y. That's in slope-intercept form. The y is just on the other side. Right? So I could graph this. Where would I start at on the y-axis? Which of these numbers is my y-intercept? Negative 1, right? So go ahead and do that on number 5. And then what's my slope? Up 2 over 1, right? So you want to put a couple points there. And then draw your line. So that's your first line. Now how about this one? There is no x variable here, meaning it's like a 0x. So the slope is 0. What type of line has a slope of 0? A horizontal line, right? So whenever you're left with just y equals something, that's a horizontal line through this coordinate on the y-axis. So at negative 3 on the y-axis, is right there. If I put a horizontal line through that, that is that equation. Okay? Is at negative 3 on the y-axis. The slope was 0x, right? They just didn't write the 0x. So how many solutions are there to this system of equations? There's just one. What is it? Negative 1, negative 3, because those intersect right there. That's at negative 1, negative 3. So you can write your answer as an ordered pair like this. Is x is negative 1, y is negative 3. If you wanted to write it like this, you could. I would recommend writing it as an ordered pair. Okay. What I mean by ordered pair is the coordinates. Okay. So there's one solution to this system, negative 1, negative 3. If I ever want to check my answer, I'll go back in and plug in x is negative 1 here, y is negative 3. This would be 2 times negative 1, which is negative 2. Then it'd be plus 3 because it's minus a negative. That would give me 1. That would work. Here, there's no x to plug in, so I would just plug in y is negative 3. Negative 3 equals negative 3. That's true. That works. So this is the solution to this system. Yes, question?
How did you get negative 1 and negative 3 together? Like,
Because that's this coordinate where they intersect, right? That coordinate is negative 1, negative 3.
okay.
So these problems say, if there's one solution, name it. There's one solution, I name the solution.